Hi guys, welcome back. Today we are going to talk about prime and composite numbers and prime factorization, okay? Prime factorization. So guys, get your notebooks out and make sure that you're in your notes section, you're writing down all these, this is gonna be a table that you're gonna reference for quite a while. Guys, so prime numbers can only be multiplied by itself and 1, okay? So we're gonna list the first few prime numbers that you're gonna need. First is 1, 2, and 3. Those are all prime numbers. The first composite number, and again, composite means non-prime, right? So if it's not a prime number, it's a composite number. 4 is composite because 2 times 2 equals 4. So it's more than just 1 in itself. 5, 6 is not because it's 2 times 3. 7 is, 8, 9, and 10 are not. In fact, the only even number that is a prime number is 2, right? Because anything even after that can be divided by 2. So 7, 8, 9, 10, not 10, 11, not 12, but 13, not 14, not 15, not 16, 17, not 18, 19, not 20, not 21, not 22, not 23. Oh, 23. So guys, for the most part, you're only going to need these ones as far as prime numbers go, and sometimes 13. But really, that's if you get down to this is good enough. Okay, good enough. So prime numbers are important for some. One thing is because we do prime factorization, and this will help you find least common multiples later. So our prime factorization looks something like this. Okay, I'm looking at example 3 here on page 118, but prime factorization of this. So 30 is not a prime number. 30 is not a prime number. We need to break that down. In fact, I'm going to do it like this. We can break it down into 2 things that multiply to be 30. Now there's a couple different options. We could do 6 and 5, or we could do 3 and 10. As a hint, anytime there's a 0 on the end, I usually multiply by 10, because 10 can be broken down into 2 and 5. So guys, 3 is a prime number, right? Go back and look at your lists. 2 is a prime number, and 5 is a prime number. So the prime factorization of 30 is, and you do these in order, 2 times 3 times 5. 2 times 3 times 5. Let's do the prime factorization of 81. The prime factorization of 81, 2 things multiplied together, we get 9 and 9. Those are not prime numbers. They can be broken down into 3 times 3, 3 times 3. So I like to circle my prime numbers just so I know I'm done. So 81 can be broken down into 3, but there's 1, 2, 3, 4 of them. Guys, mathematicians are lazy. We don't want to have to write out 3 times 3 times 3. We say 3 to the 4th power. 3 to the 4th power. That's like what we were talking about for exponents on the last one. Good. All right, so that's pretty much all you need for prime numbers and prime factorization. Go ahead and turn to page 120 and do your practice problems, A through E, and then come on back and make sure you got them correct. All right, A asks us to list the first 10 prime numbers. We did 1, 2, 3, not 4, but 5, not 6, but 7, 8, 9, 10, 11, 12, 13, that's 1, 2, 3, 4, 5, 6, 7. So then after 13, not 14, 15, 16, 17, and then 19. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and then not 20, not 21, not 22, 23. So just like we did at the beginning of the video. B, if a whole number greater than 1 is not prime, then what kind of number is it? If it's not prime, it is composite. Composite. Guys, composite just means made up of different things, right? So this is a composite figure because it's made up of 2 different shapes, a square and a triangle. So we call that a composite figure. Let's see. So C, right? Prime factorization of 81 using a factor tree. 9, 9, 3, 3, 3, 3. Circle, 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 circle equals 3 to the 4th power. Letter D says, write prime factorization of 360 using division by primes. I actually if you don't want to do it this way, that's totally fine. In fact, I would prefer just a factor tree. There's no point in going back and forth between the two. But what we could do here is 36, 10. I probably should have said that at the beginning of the practice, guys. Just do a factor tree. That's totally fine. 36 we know is 6 times 6. 10 we know is 2 times 5. 2 and 5 are prime. Go back and look at our list. 6 is not prime. It's 2 and 3. Those are both prime. And 2 and 3. So guys, we have 1, 2, 3 2s. So it's 2 to the third power. And then we have 1, 2 3s. So 3 to the second power times 5. 3 to the second power times 5. Hopefully that helps. E, write the prime factorization of 64 and the square root of 64. All right, so we'll start with the first bit. The prime factorization of 64 is 8 times 8, right? And we know 8 can be 2 and 4. 2 is prime, 4 is not. That's 2 and 2. Now we got to repeat the same thing over here for this 8. That's 2, which is prime, 4, which is not. 2 and 2. So we have 1, 2, 3, 4, 5, 6. So this equals 2 to the 6th power. Now, the prime of the square root of 64. Well, guys, the square root of 64 equals 8, okay? So let's do a factor tree for that. We get 4 times 2. 2 is prime, 4 is not. 2 and 2. So this one, 8, is 2 to the third power. 2 to the third power. All right, guys, if you have any questions, let me know. Otherwise, that is prime factorization, and these are super important, so make sure you're doing them. And we will go from there, so let me know. Thanks, guys.